So it is my sad lot to always be giving talks, you know, like the last session of the last day, right before lunch, you know, this sort of thing, when attentions are flagging. And I add to that the unenviable position of both preceding Michael and following all of you. So that it's a terrible, because this has been a really bracing, wonderful, enlightening conference for me. And so it's a terrible thing to try to have the second to last word. Should the syntax of XML, this is a really good start for the last session, isn't it? Should the syntax of XML have been scrapped in favor of S expressions? This debate, which raged on for years and which occasionally reappears, has all the ring of a religious war. The sort of Windows versus Emacs, obviously Windows versus Mac, Emacs versus VI, big endian versus little endian, and so forth. And the risks we take in even broaching the subject are manifold. A talk based on a question like this is destined to be both technical and philosophical, which is to say, bad. And try as I might, I will undoubtedly seem guilty of favoring one side or another, whatever protestations I make to the contrary. It is in the nature of religious warfare to be on one side or another and to be wrong, whichever side you're on. But my purpose here really isn't to settle this question or even to reintroduce the debate. What I want to do is use this mostly wrong-headed back and forth to shake out something that I think is actually highly relevant to the topic of data modeling in the humanities or anywhere else. And that highly relevant point can be stated pithily by asking, where does the semantics lie in our computational systems? And in fact, what I'd like to say is that this issue subtly affects the way we think about data modeling, even when we try to think about data modeling in complete isolation from any concerns about the use of data models, or even for that matter, when we try to think about data modeling in complete isolation from any concern about the use of data models, or even for that matter, computational tractability. But before I launch in on this hopefully meaningful quest for theological insight, perhaps I should explain the terms of the debate that give rise to these meditations. To start with, what the hell is an S expression? An S expression is a notation for representing tree structures, and it looks like this. We could define S expressions much more formally using an elegant recursive definition, but this is perhaps besides the main point, because anyone looking at this will say, you mean like Lisp? Yes, like Lisp. But let's lay that aside for a moment and just consider the fact that anything we could possibly want to express in this notation can be expressed using the tree structure notation we call XML. Now, I'm leaving off attributes here, but it's easy to imagine how we might add them in. If we have something like that, where I've added an acronym attribute, then we could do something like this. I don't know if that's the best way. Several methods have been proposed whereby a tree node can be annotated with a key value pair. But the point is this: these two representations are 100% isomorphic. Anything I can do with one, I can do with the other. So you might suppose that one element of the debate involves syntax, and that is certainly true. Some people have argued quite vociferously, notice I didn't say quite correctly, that XML is simply a needlessly verbose form of S expression syntax. The standard reply is that syntax matters, and Paul Prescott is probably the most sort of eloquent defender of XML over S expressions as a syntactic matter. The S expression syntax is perhaps less busy. On the other hand, do you really want your TEI document to end with 75 closing parentheses? But that is not actually the center of this debate at all. The center of the debate is the charge that XML has no semantics. Before I delve into what such a thing could possibly mean in this context, let's dive down one additional rabbit hole and ask, what does it mean for something to have a semantics? The most frequently offered answer to that question is that semantics refers to what a particular representation means. Terence Parr, who is the author of the Antler parser generator, and therefore someone who presumably should know what semantics is, says this. Loosely speaking, semantic analysis figures out what the input means. Anything beyond syntax is the semantics. Now this appears in a book called Language Implementation Patterns, hardly light reading, but not a textbook on formal languages. He can surely be forgiven for speaking loosely. But when we turn to actual textbooks on formal languages, we get statements like this. This book is an analytical study of programming languages. Our goal is to provide a deep, working understanding of the essential concepts of programming languages. Most of the essentials relate to the semantics or meaning of the program elements. Now, I don't want to, that is from a formal textbook on formal language theory. He obviously doesn't stop there, but any time we say, what is semantics? These books tend to say, well, it's meaning. Now, both of these statements, and I could cite dozens more, seem to me to beg the question, what is meaning? Or to put it more awkwardly, what does it mean for something to mean something? Obviously, this paper can only get worse. My favorite denizen of this particular rabbit hole is someone who's come up a couple of times, and that is Ludwig Wittgenstein, who offered what I continue to think is the most provocative answer to that question ever given. Some of you may be familiar with the canonical quotation in which his basic idea appears. For a large class of cases, though not for all, in which we employ the word meaning, it can be defined thus. The meaning of a word is its use in the language. It can be difficult to see at first what is so radical about this conception. Wittgenstein, in fairness, spends a few hundred pages drawing it out. Taken superficially, it might seem to be a statement about context, that how a word is used is important. But Wittgenstein goes considerably further than that by rejecting the entire notion that propositions are true or false or otherwise meaningful based on some condition exterior to those propositions. In fact, what he really says is that there isn't anything other than use in context. There isn't anything to speak of beyond this complex web of relations. What is justice? Justice is the set of moments in which the term is deployed. That doesn't make the question itself nonsensical or unanswerable. What is justice, after all, is an instance in which the term is employed. But it does make it unlikely that we'll get very far in forming a useful all-purpose definition. And since forming useful all-purpose definitions is presumably one of the goals of philosophy, we may find that posing questions like this gets us exactly nowhere. What is useful about all of this for my purposes, though, is the fact that this idea of meaning in use gives us not only a way to talk about computational representations, but as a way to describe computation itself. Computation, stated in the most minimalistic way possible, is about taking information from one state to another. In the normative case, it is about taking some linguistic construct and producing another linguistic construct, though that is not at all essential. If you have a process that can take information and produce more information, we call that process a computation. It's what happens when you press the equals sign on a calculator, and it's what happens when you friend someone on Facebook. The fact that we have some process by which to effect that transformation indicates something in particular about the information with which we began. We say that it has a semantics. And this restates Wittgenstein's point quite succinctly. The information has meaning, has a semantics, because we can produce other states from it, states being anything from reorganizations to physical actions. In the absence of such productions, whether actual or potential, the information is literally meaningless. And while that condition might be rare, it sets a boundary condition on semantics. Most computational representations have a semantics because it is at least possible to imagine computations being performed on them. This is perhaps why Friedman and Wand, from whom I drew that previous quotation about the essentials of programming languages having to do with semantics, go on a few sentences later to say, the most interesting question about a program as object is, what does it do? If meaning is use, then who can argue? So when the Lispers say that XML has no semantics, they are presumably referring to the fact that by itself, XML has no inherent ability to produce anything at all. you need to describe that semantic meaning somewhere else, which is exactly the same as saying that you need some process by which that representation is either transformed into some other kind of representation or otherwise results in another representation being produced. But is that any less true of S expressions? Isn't an S expression also a representation in search of a means by which it can be translated into some other representation? What could possibly cause someone to say that S expressions have a semantics while XML does not? And I've read this entire flame war, so you don't have to. Okay. But the answer to that question, when some, S expressions has a semantics while XML does not, the answer to that question does have to do with Lisp, because in Lisp there is no inherent difference between the representation you use for data and the representation you use for the process, i.e. code. This, by the way, is called homoiconicity, and it's an inherent property of all languages in the Lisp family. The most striking example of homoiconicity outside the Lisp family is, wait for it, XSLT. In either case, it means that any code you write is also a data structure in the language, and conversely, any data structure you create is at least potentially an executable process. I say potentially because the Lispers are completely and totally wrong when they say that S expressions have a semantics. They have a semantics if and only if you also have a way of taking that representation and using it to produce something else. That is to say, S expressions have a semantics if you also have a Lisp to process them. The consequent notion for XML is that XML has a semantics if and only if you also have a way of taking that representation and using it to produce something else. That is to say, XML has a semantics if you also have a schema combined with some way to process it. But notice the difference there. If you have S expressions, you need a Lisp runtime. If you have XML, you need a schema, which is to say a grammar description combined with a type and structure ontology, what we would call, in this context, a data model, combined with a presumably Turing-complete language. The difference, in other words, has less to do with angle brackets and parentheses and much more to do with where the semantics lies in the overall system. It is possible, of course, to process S expressions without Lisp. It would also be possible to separate the grammatical description of type and structure constraints from the entity responsible for affecting the transformation and still be doing Lisp. We are not talking about some kind of new affordance offered by Lisp, some deficiency in the XML ecosystem, or the other way around. When it comes to taking things from one information state to another, either system could be designed either way. So my question is this: does it matter at all where you put the semantics? And the answer to that, I think, is yes, and for more or less the same reasons that syntax matters. The XML ecosystem implicitly imagines a radical decoupling between the act of data modeling and the act of processing data. In fact, it breaks the act of data modeling itself into several discrete stages, which, in practical terms, translates into a decoupling of the social act of marking up texts from the social act of modeling data, and both from the social act of processing data. I use the term social act as a way of designating different potential functions, job descriptions, if you like, in the overall job of computation. You can be the person who decides how a grammar is applied in a particular instance, or you can be the person who defines the grammar, or you can be the person who uses the grammar and the document to translate the information to another state, or obviously you could be all three. What the Lispers argue for is really a world in which the three things are combined. Some partition of roles is of course still possible, but in practice, the Lisp ecosystem more or less demands that data modeling and data processing are never far from one another. While it's possible to imagine an S expression tagger, maybe that would be a parenner, it is less easy to imagine that person not also being, at some level, a programmer. But forget about Lisp, again, because the real issue is not whether Lisp is good or bad. The issue is whether the distributed, decoupled model embodied in the XML ecosystem limits or expands our ideas about data modeling as compared to a more centralized workflow in which data modeling is never far from data processing. And here I will risk starting my own flame war by saying that practically speaking, it does. It does because it is not possible to fully describe the semantics of anything apart from the processing that is enabled by the semantic relationships so described. An XML schema, and here I'm talking about any kind of schema at all, describes a grammar. It is in fact explicitly based on BNF grammars, which of course are used to also describe programming languages. This, and not any particular instantiation, is the data model, a statement which the designers of XML, by the way, are in full agreement on. Typically, a schema defines a set of data types and a set of ordering constraints, which again are semantically meaningful only at the point that the document is processed. But why stop there? Why not use that schema to define a set of control structures for processing data? Why not state whether variables are bound late or early, lazily or not? Why not define a set of data structures into which the data may be trivially but predictably transformed? Well, you say they did. It's called XSLT, and it's separate, and it's optional, and that's good. And you might be right. In fact, I think you are. But the fact still remains. Every data model is asymptotically approaching a processing model. I would even suggest that the question, are the data models we have proposed for the humanities sufficient to the task, is equivalent to the question, does the semantics reside in the right place in our model? Not because shifting the semantics around gives you new processing powers, because it does not, but because to the degree that any data model attempts to stay neutral with respect to future processing regimes, it must limit the practical affordances offered by that model to the data modeler. To do so might be to commit an act of magnanimity. To construct a data model in the absence of any particular judgment about future processing is presumably to let 1,000 processes flourish. But it is also to limit what can be modeled, because that is exactly where a good number of the decisions about semantics are being made. We may comfort ourselves with the thought that every step up the chain of abstraction allows more flexibility at the processing level, but a dark voice remains and should remain. Every step up the chain of abstraction also means separating further and further from what is presumably the point of all of this, namely the attempt to exploit the computational tractability of the data. To give the processor more power is necessarily to give the data modeler less control. Not just less control over the processing, but less control over the data model itself. So we really must ask ourselves, does having less control over the data model, which is not the same thing as saying more flexibility, make sense for our data? Should we have gone this way? Should we have attempted to create a more tightly coupled ecosystem in which the line between data modeling and data processing vanishes as a practical matter, as it does, I would argue, in SQL? Should we now think about doing that? I don't know. And I'm sorry to end with something so obviously decoupled from a practical recommendation of any kind. But I take the point of this symposium to have been, can we do what we want to do? And I think it's at least apposite to point out that as long as we're talking about what we want to do, we are talking at least partially about what our data models cannot do by themselves. So, thank you. Yeah, bring it, man.
Strategic move. I thought that was brilliant. Thank you. One of the things that I thought was very interesting that was a really critical point was when you identified the relationship between the design of the XML ecosystem and the roles played by different people within those workflows, right? And in fact, I would go further. I would say that actually XML takes a step back towards the Lisp model, away from what SGML had implemented.
Oh, that's true. That's good.
And SGML reflects a design that was very deliberately maps towards those roles because it's designed for a publishing system within which you have authors or content creators who create, the stuff and mark it up because it needs to push through the system. Yeah. And then you have editors that define the rules, and then you have production specialists who then optimize the processing of the information for the particular output, right? And so the design of that system is actually, this comes out of IBM, among other such places. But it's very reflective of a certain sort of industrial,
Cultural
information production and management strategy, which is appropriate to certain kinds of information also.
So is it our kind? I guess is it.
Well,
is
I think that's a.
And I really don't make, I really don't need to take a strong stance on this. I
Right.
really just want to.
Yeah, I understand, but you see, I think that the question, is it our kind, is actually vital, because one of the reasons why XML has worked so well is because it does take a step back towards the Lisp model. It says that, you don't have to have your schema up front. You can go ahead and, manage things sort of with the markup and just the style sheet, and then kind of the schema, and sort of, it gives you another sort of way to get into that cycle, so that you don't have to, do everything up front waterfall style, right? And that's been really, really tremendously important and useful for us, right? But you see, the thing is that the dark side of the Lisp model is that you can't really do anything unless you're a sort of an auteur who understands everything at all points, and it doesn't allow you to split things out into
Right, and worse than that, I mean, XML, now there's XSLT, but XML also imagines that, like, when it says no particular processing regime is imagined, I mean, it's absolutely doesn't care what language you use or what platform you use or anything like that. The answer to the question, how do you do anything in the Lisp model, is Lisp. How do I transform documents into other S expression in Lisp? How do I extract information? Lisp. How do I search the documents? Lisp, right? Is that no wonder the Lispers like it. But that's but I mean, yeah.
You actually do hear that kind of rhetoric out of the XML space also.
Yeah.
And which isn't to say that everybody loves XML syntax for everything, but at a certain point, the syntax fades away into the data model itself, and into the particular affordances of the tree hierarchy. And so I think the point here is that that splitting the things out is actually very, very good, because it allows us to distribute work and to work together and to communicate across boundaries and to optimize our roles and to.
But would you grant to me that it's subtly reducing the affordances of the data modeler as the person who occupies
Absolutely,
it?
it's a compromise. There's a trade-off.
There's a trade-off, but that trade-off frightens me a little bit, because especially in the context of a symposium like this, where we want to take data modeler.
Well, what it does is it puts you in a position where you can do those things, but only if you can affect communications within a larger team, right? And that which is a good thing too, right?
So we should have invited the programmers to this.
Next
SLT person.
Sorry.
Yeah, first, I'm not thanking you for providing such a nostalgic brief just before leaving tonight, and having to spend no full night, because I will think again about Lisp and Prolog, like we had this discussion yesterday. I was an old fan, and I just have seen Lisp fade away. I'm going to cry. So it's really, no, you should have avoided that. Anyhow, I mean, I took two major things which are essential for our discussion here concerning data modeling. I would put that on the horizontal and vertical line. First thing, horizontal, when you speak about isomorphy, this is essential that when we are reflecting upon ourselves, when we model something, that we can take this stance of saying, look, whatever tool we have, and we can just draw things on a paper, like draw a tree if we really like trees. The isomorphism is essential, and it is reflected in orientations like taken at the OMG with the notion of meta models, or what we're doing also in this ISO Committee on Language Resources, where we describe mechanisms by which, through meta models and decorations with data categories, we actually create classes of models which in turn can be instantiated in any kind of XML vocabulary or whatever syntax from the past we don't want to mention. The second aspect, you pronounce the word affordance, and I think you went, because it's the purpose of the talk at the end of 3 days like this, you went very far, saying basically you cannot think of any kind of modeling without thinking about processing. When you take some distance a little bit, this notion of affordance says, okay, when you start modeling data, is to contemplate a certain series of processing that you would like to do. As a researcher, you would like to search the data, you would like to be able to have, through those affordances, the capacity to link and create new concepts which are more on the research side than just the observation side. So those affordances are essential also when modeling things. What are the concepts on which I want to create a certain stability in my data? So it's not just one single-sided orientation for one type of processing. It's really like with statistical methods.
Although I would point out to you that the TI guidelines disagree with you on the fourth line on that, right? I mean, they disagree with you very quickly on the idea that what you do to begin the data modeling process is think about the processing regimes you want to enable. That's the way you're not supposed to do it in the XML ecosystem. I mean, you know, I mean, like that's. I mean, you may think that's crazy, and so do I, but.
A project, a very concrete project, having to encode some sources in the humanities, starts with trying not to overkill the use, for instance, of the TI guidelines, saying what are the concepts I want to have in my text that I will annotate. Are persons essential in my text, and I will annotate them, otherwise I disregard this part of the TI guidelines.
But
the TI guidelines is a marketplace to create possible affordances.
Right, although it's interesting because what you just said is slightly different from the argument Julia was making yesterday or today, so it's all blended together. That if we look at the odd files, what we will see is change. Like if we can arrange odd files and analyze them, what we will see is the scholarly community having a changing conception about text. And I, you know, I think the way I would say that, and I think maybe the way Laurent would say that as well, is that actually what we're seeing is changing process requirements over time. And that is where the changing conceptions of text are occurring, right? It's not like we do the odd, we look at, you know, we change around the odd files because our notion of text is changing. That's too direct, right? Really what's happening is we want to do new things and we keep adjusting the odd. And again, yeah, you know, I mean, and I think this is really what I'm trying to talk about. Is like where do we put the line between, where is it our job and somebody else's job to think? I mean, you know, because I agree with you fundamentally, but I also think that we are, when we talk about data modeling, we are implicitly drawing a line, we're locating a point on the slope that at which modeling approaches processing. And and that was really all I'm trying to draw in this paper is, do we have that line right? And we may, you know, I mean, as a practical matter, we may. Well, maybe. I mean, I don't know. I mean, I would also point out that you know, XSLT bears in a tremendous family resemblance to Scheme. And I think on purpose, because I think they were thinking about this exact issue when they wrote it. I think they were, this was one of the issues they were thinking about. Which of course the Perl programmers never thought. Sorry.
First of all, thank you very much, Steve. This is absolutely fantastic. And I ate it up, and I'm going to probably eat it up again.
You're very kind.
I want to take up. I want to hold the position of, I was going to say the devil's advocate, but I think perhaps after what you said to Laurent, I'm playing the TEI advocate.
No, devil's
in saying that I'm a fan of believing we can decouple our semantics from our processing. And that comes from my personal history. As many in the room know, I worked with the Women Writers Project generating these texts, building not necessarily good models back then, but models of these texts without any possibility of processing, without any hope of processing for years to come, in a complete vacuum of a processing environment. Vaporware was my best friend. I had to develop the semantics without any processing. And I think that we can still usefully build models that represent our thoughts about a text and defer the processing either to later in time or to someone else down the road at some other place in our institution in a very useful way. And maybe I'm wrong. Maybe that's
well. I mean, can we? Well, we have. I mean, it's not like can we? I mean, we're sure. I mean, we did, but did we do it? I mean, because let's do as a thought experiment, and I was talking about this with Wendell, let's imagine liminal. One of the things that's exciting, we'll go back to the very first talk. What's exciting about liminal, to me, I mean, there's practical reasons why you might want to model things and allow overlapping hierarchies and have them in the same thing. But one of the excitements about liminal to me is I see it as a kind of sort of anarchic experimental playground for reimagining data modeling. Because we could, in a moment of perversion, we could say, you know what, this language is going to have no nouns in it. There's going to be no such thing as italics. That's not going to be, there's only going to be italicize. Everything is going to be a program, a processing instruction, right? That would be a very radical view of, yeah, well you could. With are you thinking of things like COCO and event-based? Maybe not, because they could be. Yeah, TROF, right, TROF, and yes, absolutely. But with the liminal syntax, you could have, it's possible, and I'm thinking on my feet here, but it's possible that the overlapping hierarchy, if you think of those as functions and not as ontic boundaries or objects or something like that, then it's possible that the problem of overlapping hierarchies disappears in part because you can always run functions in parallel. You can run as many as you want. You can say this event started and this event ended, as opposed to saying this is a discrete. I don't know. I have not sat down and figured that out. But my point is just this: that I wouldn't dispute that. First of all, we have done it, and second of all, we may have done it for all the right reasons and have the best possible system. On the other hand, as long as we're here to talk about data modeling, I really do want to think about other worlds and whether those worlds might have given us a different view. Because I presume this symposium arose in part with a kind of anxiety. Do we have it right? Do we have the right tools? Do we have the right thoughts? Do we have the right affordances? I mean, it seems to me that's a way to ask the question is, well, maybe it's all wrong. Maybe the list guys were right. The list guys were not right, obviously, but maybe they were. Maybe they had something to say.
Okay, then Max, and then Wendell, and then Max.
I thought that was very good. So I think you raised exactly the right point, right? It's not only in the 1990s you could only model what you thought about the text, but it's in the human history you could only model what you thought about the world, right? And right now you can actually start processing, right? It's the interesting thing that we have applied models and we have collected the data, now we can actually process and actually take a look if it makes sense or not, right? We can look at this text and you can say, is Sid's model better than the model of this other guy, for example, right? And that's a huge shift also. That's the race of data scientists versus data models. Right?
And what better means in that context is also going to be contested.
Yes.
And I mean, what I would say is, in the good old days back in the 90s, we didn't actually have semantics, but we had claims about semantics, right? We had, in the sense that
The strict computations.
in the sense that Steve is talking about, and we were declaring a semantics, and we were making semantic commitments because our data was like this, which meant it was not like that. And therefore, you could certainly say there was a semantics potential in that. And in fact, I think that one of the fascinating things about descriptive markup regimes in general, and Trevor was talking about this yesterday, is the way in which we actually do try to maintain a kind of discipline of non-commitment to particular operations in favor of, it's much like Fotis is just talking about with respect to the scholar talking about the Enlightenment. There's a climate, which means that you decide what we mean by climate. And that, in fact, I want to see what you're going to be doing with liminal, but I also think that Sid is going to be able to use it to write, to describe data structures, which he has no idea about how to process, and will not bind to.
Poor Michael is over there thinking I'm going to reinvent Roth, but actually I have a grander plan. What I'm going to create is the TTI. It's the Text Transformation Initiative. And it imagines that, I mean, it's possible. Like you could say, we're not going to define objects in a 3,000 tag set. We're going to have user contribute. We're going to describe functions and operations. I mean, I'm pretty convinced that's insane. But it's it's fun, as Alan pointed out.
I have to gloss this in the sense that I think you say we had no idea what we were going to do with it, but that's actually not quite true. And it's a little disingenuous, but it's very importantly so, because in fact, we had what you might call an intermediary processing model. That is to say, we knew what kind of people were going to want to do what kind of thinking with our text. We didn't know what kind of specific tools they used to do those things, but we knew that they want to study people, and we knew that they want to study genre, and we knew that they want to study these things. And I wonder if it's just a question of identifying processing at the right level of specificity.
You had the dream of processing at least.
Right, but you also had the ability, and you did not fail to take advantage of the opportunity to validate against a scheme.
Sure. That's what.
Dirty
After a certain point, yes.
For the sake of constant, I mean, we're talking about isomorphism. It's like isomorphism all the way down, right? I mean, it's sort of when we are explicitly not talking about our ability to go from one input to another output. We're not talking about can you do it or can you, we're talking about a kind of like, have we separated the concerns right? Have we put people's mental energy in the right place? I mean, these questions seem to me paramount, and they're connected to our architectures and our models. And it comes back, I did say on the beginning, I want an answer to the question, why is our workflow look so unlike some of the other workflows that are used? I mean, it was very interesting. Elka, she said, put up her data model, Weka, R, rapid minor. I mean, that's a very different way of thinking about data modeling, and not an illegitimate way of thinking about data. I mean, we're sort of different, maybe for good reasons, but what others?
I just want to say real quickly before you move to the next section, I think Wendell's pointing at the term potential semantics. Using semantics as
Potential.
that's a real powerful concept.
Yeah, potential semantics.
Well, thank you all.